Hello again. So today video it's about attempt to fix a Charsoon Antimatter 250 watts, which suddenly, after a few experiments of charging, discharging lithium batteries or cells, suddenly turns with a connection breakdown display. Well, the machine is already open. I did measure the MOSFETs and it seems like everything was fine with the MOSFETs. I changed the MOSFETs, I replaced the components, but still the same connection break on the display. In fact, I start recording from the middle somehow because the beginning of the thing is not really interesting. So after measuring all the components and of course doing some research on the internet, I found the problem. It's a Zener diode, as you can see in the next video. Alright, so checking all the components, all the MOSFETs, they've been okay, so it wasn't really necessary to take them out and, to mess with these things around. But in the meantime, I found Zener diode. It's in this position here. It's D16. This one right here. So this one was in short. It's supposed to be a 20 volt Zener diode. And here, you see this little guy here? That's a transistor. It's D26, probably burned because of over voltage input. If we measure this transistor, we have a very clear short base collector. The base is down here, absolutely shorted base emitter, but very clear short, so no doubt about that. So 5CW transistor, and it's a general purpose BC807. I'm gonna proceed to replace this transistor and to find the Zener diode. Well, I couldn't find a 20 volts Zener diode, but I found a 12 volt, and here I have a 7.5 volts. So this can be tied in series and I'm gonna have 19.5 volts. This is pretty close to 20, so that will replace the Zener diode in short. Okay, so here we have the diode made by two Zeners, 12 volts and a 7.5 volts. Let's check for functionality. There we go, diode mode. That should be fine. Let me try to take out this little transistor, this little guy here. I just used my soldering. I know it's kind of messy, but no, it went well. That's the guilty. So we have the base, emitter and collector. Now it's time to find a transistor like that. Well, I couldn't find a SMD, but I found this one, so it's looking like okay for this job. Now I have to plant it on the board. Shouldn't be a big problem. Base, collector and emitter. Base is in the middle, so I'll do a different approach for a better placement. I'll just cut the collector like that. Let's see if it fits. Yeah, perfect. Yes. So now I have to bring all these guys down, make them a little angle. Emitter and collector are in place, and that's the base there. Looking good. Okay, Now let me have a... So, luckily, this guy is fixed. Let's see. Power on. Yeah. Let's have a little cell. First, polarity check. Well, doesn't say anything. Reverse polarity. Okay. Good. So, the polarity, it's working. Let's have a discharge. Yes, people, it's working. Perfect. And let's have a charge, 800 milliamps. Oops, something burned. What can be wrong? I heard a clear spark. It's these guys here, very possible. Okay, let's take out those MOSFETs and replace them with something reliable. Look there, nice and clean. Okay, let me find some MOSFETs to join the party. 31, 32, let's see. No, I got something else here. 42, 27, yes. I'm not sure if it fits in there. So it'll have to be shorter. And that sucks. Leveled somehow because we need to have the thermopad, okay? Something wrong with that MOSFET. Discharging is fine. Discharging is perfect. Okay. What can be wrong? What can be wrong? Let's have another test. Discharging with 2 amps. It's working great. Let's see which of them is getting hot. As the main supply. Okay, I got these two guys here. 1, 2, 3. In fact, 1 and 2. This and this. The last one, it's cool, no problem. So these two guys are discharging. This one and this one. And here, this one too. It's pretty hot. All of them are working. 2 amps discharge. Really? Let's check that. If something. That's true. 1.93 amps. Yeah, it's working. So I fixed the discharging part of the things. Beautiful. Now, what's wrong with this? Let's clean around. Gate is coming from this transistor here. This transistor from emitter is going to this 1 ohm resistance to the gate. No short here, everything is fine. And this one goes to the source here, and this guy. Okay, let's check this transistor first. Good. No problem. What about this guy? Good. Good. This is good also. Okay, that's another configuration. But anyway, this is okay. Can be the diode inside there or what? This is shorted. Can't believe it. This is gone. Oh, so gone. Yes, so unfortunately my machine gave up, and I found the single explanation is this connector, which is improperly suited for getting into this motherboard, and I can see sparks and I can hear noises, and I'm pretty sure everything starts with this one, because oxidized and doesn't have a proper contact, probably gives me peak voltages which destroyed evidently the Zener diode D16, which is supposed to be 20 volts. You know, if it's getting higher than 20 volts, then it's shutting down the circuit. You know, it's shorted, it's getting short, and put all the things down. So finally, if you have this connection break on the display, first check this diode D16, and then check and replace the PNP transistor here, this Q26. As you could see at the end of, almost at the end of my videos, after replacing these parts, the machine starts discharging properly, but something wrong happened with the MOSFETs around here. My mistake was that I was jumping straight to the MOSFETs, because my experience with IMEXs just pushed me to replace the MOSFETs, even if they prove okay measuring in diode mode. This board from Charsoon Antimatter 250 watts, it's equivalent to if Icharger 106B and Turnigy Reaktor 250 watts. Same board, exactly the same board. So check for similar videos or similar documentation about fixing this connection break display. Don't jump to soldering things before having a proper idea about what's happening here. I found later than when you have an extra voltage or higher voltage than 18 volts up here, this diode is shorting, and that transistor is ruined. So I could fixing it being a little bit more patient, you know. Don't get exciting. Do homework first. Okay, so now let me see. I can hear the buck converter is trying to do something. I can hear a noise there, so we still have a kind of oscillation. My power supply delivers like 300 milliamps, and I'm not sure. Something is getting hot here, so we can take a look. This is the main processor, which I feel warm, not exactly hot. Yeah, so this is the processor here, which gives me like 51 volts, and nearby it's another circuit, 34036 PELSA, which I suppose is the buck converter circuit, which also goes up to, let's see, 5160 degrees or something. Okay, so nothing else to do but just get rid of this. I'm pretty sure the processor, it's gone because of the high voltage. Nothing else to say, nothing else to do. Okay, so that's it for today. Thanks to my sponsors, thanks Jack, thanks Vlad from Ampere Records and Radu G, and see you next time with some other projects. Bye!